Hello, everybody. Thanks once again for joining us today, and welcome to Scaling 5G to New Frontiers with NR Lite. Terrific to have you with us. 5G, as I'm sure you all know, is designed to support diverse services on a common technology platform. And this, of course, includes the machines and devices of all kinds that are critical to, on the one hand, enable connected industries, but also to support consumer-centric Internet of Things applications. 5G IoT to date has focused on low-complexity devices, such as asset trackers and utility meters, and on high-performance applications, such as control of robotics or different kinds of industrial equipment. There is, however, also a clear need to address mid-tier devices, such as wearables, health monitors, vehicle trackers, voice assistants, and a whole range of industrial sensors and other industrial-type devices. The mid-tier of cellular IoT is served by LTE today, but there is a strong requirement, we talk a lot about this, for a 5G native solution. The industry sort of response for this, but for mid-tier 5G IoT connectivity is NR Lite, the subject of this session, also known as RedCap or reduced capability devices in 3GPP. It was introduced as part of 3GPP release 17, and NR Lite now bridges the capability and complexity gap between the high and low end of performance in the 5G IoT systems we have today. I'm actually really excited about it. Mid-tier, I think, has many diverse and useful applications. I think when it's rolling, it's actually a technology that's going to scale rapidly and make a really big contribution to, making 5G the sort of platform that we really want it to be in terms of something that different companies and developers and so forth can innovate on, particularly, of course, for these machine-type communications. And so that's the focus of the webinar today. We'll discuss what NR Lite is, investigate progress on standardization, and then position NR Lite in the wider 5G and Edge ecosystem. My name is Gabriel Brown. I'm Principal Analyst with Heavy Reading, where I lead our mobile network coverage. I'm your moderator for today. I'm joined by our expert guest speaker, Dr. Kiran Mukavili. He's Senior Director Engineering at Qualcomm Technologies. Kiran, great to have you with us. I'd like to say a few words about yourself and tell the audience who you are.
Sure. Thanks, Gabe, and thanks also to all our audience here for joining us this morning, afternoon, evening, depending on where you are, for our webinar. We're very excited to talk about this topic. I'm a Senior Director of Engineering at Qualcomm Technologies, and in particular Qualcomm Wireless Research, as Gabe had mentioned. And in my role, I lead the systems research for 5G Advanced and 6G, and I'm also responsible for all research and positioning within our Qualcomm Wireless Research. Very excited again to talk about NR Lite this morning, and look forward to our interaction here.
Great, good stuff. Thanks, Kiran. So I'm just going to give a very short introduction in a minute. Kiran will actually give us the large bulk of the presentation today. It'll also be on hand for Q&A that we've built into the timing at the end of the session. But you can submit questions at any time. Kiran is a really great person to ask. He's very technical, knows tons about this. He's genuinely a world expert. So if you have questions, he's exactly the type of person to ask. I know I've just had a quick look at some of the people logged in on the attendees list. I know there's a handful of people there who are also very expert, but do take advantage of that. Kiran is very open to taking the questions. So very quickly then, there are, according to the Omdia Cellular IoT Market Tracker, around about 2 billion active cellular IoT connections worldwide today. Some of these are 2G, 3G, of course, but the large majority are LTE. And that's really split into two categories. On the low end, NB-IoT, it's especially big in China, and Cat-M or EMTC. And then there's another category, kind of Cat-1 to Cat-4 sort of range, that's also a very big part of the volume as it happens. NR Lite will come in and target, we'll hear a bit about this from Kiran as we go through. To my mind, is really going to come in and target around about Cat-1, but may very well scale up and down the performance ranges from there. And as I say, Kiran can kind of explain a bit more about that as we go through. The chart here to the left shows from the same tracker, it's a different set of data, shows cellular IoT module shipments by application types. Now, my reason for showing this is not so much the absolute numbers, although it does show a growing market. And remember, each year these are additions to the base. So the cumulative base is growing pretty strongly, albeit, of course, there's a number in the base that drop out every year and so forth. But really, I wanted to emphasize that it's a very broad-based market. You know, the diverse application categories are represented here by the different colors you can see. It's not dominated by one particular type of device or app. So I think that's really important to have a strong ecosystem. 5G is currently actually a very small part of this forecast. I was talking to Andy Brown, who runs the service for Omdia. Obviously, he's looking at NR Lite and RedCap and different things. I think at this stage he probably should speak for himself, but he was telling me he's really thinking that it's going to come in and take, as he sees devices and refreshes the forecast, which he does quarterly. So a lot around the Cat 1 sort of area would be probably the first place he sees it to start sort of taking volume from the LTE devices. Now, just very quickly before I hand over to Kieran, I think it's super clear 5G needs IoT solutions as native solutions, right across the tiers. This is so that it can become that sort of true platform technology that, we can create different services and value from. This is true in both public and private network. So much of the 5G story is around connected devices, and yet today it's primarily been volume in the smartphone sector. So I think there's a need there. There's also quite clearly a need to offer a long-term migration from LTE networks. Very important when you start to think, certainly over decades, really, about things like spectrum refarming and so forth. And then we also need to enable direct to 5G deployments for new IoT devices and applications, again, in public and private networks. Certainly, there's many types of things we could foresee that ideally we would deploy native to 5G rather than start on 4G and migrate over. So I think that's probably the burning driver, really, for this technology. It's also the case that 5G does bring value to IoT, all the various different 5G system capabilities. Talk a lot about them, but scalable numerology, beamforming, positioning, service exposure, quads, all sorts of things. These should enable better and more efficient IoT services. A number of ways you can see that. And then just the basics of being able to leverage all this global investment in 5G networks and coverage across the wide area. There's a lot that 5G can contribute in its own way. So with that, I'm going to hand over to Kieran for the next section. Kieran, the controls are yours, and your first slide should be showing.
Yes, it is. And thank you. Thanks, Gabe, for that introduction and for setting this up. Again, welcome everyone to this webinar this morning. The topic is scaling 5G to new frontiers with NR Lite. As I said, we're really excited about this new device category that's coming in. It's going to really put 5G in steroids as 5G adoption takes up. So we organized a discussion this morning to mainly address these three questions, which we think should give you all a very good background for, first of all, where 5G is going, and also for the role that NR Lite is expected to play in this 5G evolution. So you'll see that the three questions that we'll get to will be around, first of all, why is 5G a key driver for the connected intelligent edge? And we'll also spend just a minute or two on what we also mean by the connected intelligent edge, which is a very important concept. Then the second question that we'll get to is, how is 5G addressing different device requirements? And Gabe also got to this in his introduction about how we have IoT, which actually spans a wide range, and how do we make sure that we have an optimized solution for each one of those segments? And finally, get into the technical aspects of NR Lite. What is NR Lite, and what is its role in fueling the future of 5G growth? And we will make sure that there is enough time left for Q&A. So with that, let's jump right in. So 5G, again, as we have all seen, 5G has already started off being a phenomenal success. If you look at the deployments and adoption of 5G and compare that with how the deployments and adoption has happened for the previous generation technologies, 4G and 3G, or for that matter, 8G in the past, 5G adoption has been really rapid, and the number of operators that have been scaling up, the number of devices that are available, even 4 years into 5G standards becoming available, it's unprecedented. And what this also actually paves way for is the vision of 5G, where 5G was expected to come in and expand the mobile ecosystem to new industries, as you see, starting with precise agriculture and going all the way to smart city, traversing various industries and applications along the way, and really rocketing this digital economy to numbers running into tens of trillions of dollars, as you can see, based on multiple studies that are coming out. So 5G is expected to play this huge role in making everything digital. So with this kind of role that's already shaping up for 5G, what's also going to happen is we're going to see more and more devices that are going to be connected and gathering data. So pretty much sensing is now, and sensing in various forms is built into every device that we interact with on a daily basis. And when this happens, with all the data that's getting collected, there's also a very big role for AI techniques. How do we process this data? How do we gather intelligence and learn from this data? And the question is, where does this happen? Does it continue to happen deep in the cloud, in the central cloud? And if that's the case, how does the data get all the way from the device to the cloud? And is every device capable of carrying this data back to the cloud? And is every network able to scale up to carry this kind of data into the cloud? And is it also the most efficient way of doing this? There may also be other concerns, including privacy, where you may not want the data to leave your premises in some cases, or reliability, latency in some cases, because even if you make a decision, process the data, but then if it passes the deadline, then it's not of much use. So you may have to meet very stringent latency requirements in some cases. And finally, there's cost to pay. The more or the longer the bit travels in the network, the bills go up, including energy utilization, as well as the charge that happens to the bit. So for multiple reasons, you may actually want to keep the processing close to the edge, and that would be starting with the device itself. We need to see how much of compute and intelligence we can build within the device. And there are scenarios where they're just given the device form factor and size and constraints. We may not even be able to do it completely within the device, in which case build some of the intelligence into the edge, and between the device and the edge, make sure we have all the intelligence that's needed to process most of the scenarios, and only take the data into the central cloud when it's needed and when the applications can tolerate. So this is the notion of the connected intelligent edge, and this is possible mainly because of 5G, because of the low latency, high reliability, high throughput connections that 5G can offer between the device and the edge cloud. And this is going to be one of the big components that's going to enable the powering of digital economy that we talked about in the previous slide, which is expected to put us in the tens of trillions of dollars of available market. So as a result of what's 5G, or what 5G is able to do with the intelligent edge devices and the intelligent edge and connected intelligent edge, we already start seeing that there is a huge transformation that's happening in multiple use cases and scenarios, including transportation, manufacturing, industrial, retail. And some of these things were covered in our other webinars. Not get into too many of these details, but what we will focus on today will be all the scenarios where IoT starts playing a role, and how we map up these use cases among various classes of IoT, and the role of NR Lite coming into these use cases. So 5G, again, as you all know, started off with release 15, and there was an early drop in 2018 with even the early devices and deployments happening soon after that. And that's just the starting point. 5G has been constantly evolving even beyond release 15, where 15 was focused on eMBB, and then 16 start getting into expanding to other industries and enabling verticals. And release 17 is where NR Lite has been defined, along with many other features that came into the 5G fold. And then there is an evolution path defined into release 18 and beyond as well, even for some of these features, including NR Lite. And we'll see some of those features as we get into the webinar today. So suffice to say that 5G is not one and done. It's a constantly evolving technology which is able to encompass all the evolving needs of various applications as we go along, as 5G adoption takes up. So with this, let's now get into more details about NR Lite, starting off with what kind of applications and requirements we should be targeting for NR Lite.
Kieran,
yes.
As you go into this, Kieran, we just had one question come in. I think it'd be worth addressing right away. The person asked, are you using NR Lite and RedCap interchangeably?
Perfect. Okay, I think it's definitely worth clarifying right away. Yes, NR Lite and RedCap are being used interchangeably in this presentation. For most part, we will be using NR Lite, but it is same as the release 17 reduced capability or RedCap as defined in the 3GPP specification. There is a little bit of story behind NR Lite and RedCap. Fortunately, we don't have time to get into that, but suffices to say that we are going to use it interchangeably. Thank you. Thanks, Keith, for the clarification.
Yeah, good stuff. Karen, please.
Yeah. Yeah, so if you look at this chart here, what you'll see is IoT requirements. IoT comes in all shapes and forms and sizes. It's not just one set of applications, it's one set of requirements. And what we started off early on in release 15 and release 16 is mission critical IoT and massive IoT, which were addressed using URLLC and a little bit of EMBB, but mostly URLLC, and then EMTC and NB-IoT. But then as you look at all these other use cases that start to come in, including surveillance cameras, health monitors, industrial sensors, and even high-end wearables, you see that the requirements for these use cases fall right in between what URLLC can address and what we can address using massive IoT. And there was a big opportunity and really more of a requirement for 5G to come in and address this space. And that's exactly what happened in release 17 with NR Lite or RedCap. So how do we break down the requirements of IoT? So when you see this, you can think of the drivers for IoT or the decision factors are typically based on latency, throughput for the application, density of deployment, complexity that we can afford to have for the device, and the battery life that's expected of the device just because of the use case that it is in. Maybe we are not able to go charge the battery or replace the battery on a frequent basis for some of the applications. And along these metrics, you'll see that when the performance requirements are extremely high, including latency, throughput, density of deployment, again, is one of those things where maybe you can afford, in the case of mission critical IoT, not to have a very large density, but really push the other vectors to the extreme. So that's your mission critical IoT with the corresponding bars. They're just giving you pictorial representation, just to give a sense of the scale of the magnitude that's needed for each one of these vectors. And then on the other extreme, you have 5G massive IoT, which is mainly covered using EMTC and NB-IoT, where latency, these are going to be tolerant in terms of latency. Throughput can be low. Density is expected to be very high. Complexity has to be very low. And then battery life, again, on the longer side, as long as possible, just because for most of these use cases, you may not even be able to go replace these batteries, and you may even have to throw away the devices, just given the logistics involved. So that's where you are, but you will see that there is this band in between with moderate requirements in each one of these vectors, where there's a big opportunity for 5G to come in and come up with a device category which can so moderate latency, throughput, and complexity and battery life. And that's exactly where NR Lite sits. And what can we do with this kind of a device? If you have this, and here are a few examples where these devices fit right in. And some of the verticals where this can happen include smart cities, indoor enterprises, industrial IoT, consumers, and you can see some of the devices within these verticals, like, for example, in smart cities. If you look at what actually enables smart cities, starting off with looking around the city, real-time parking status and video monitoring using surveillance cameras as may be needed in some critical places, smart city command center, asset tracking, smart utility meter, and these are all use cases where clearly EMBB kind of requirements are not required. We do not definitely need gigabits worth of throughput, and corresponding, we don't have to carry the complexity that's needed to carry that kind of data rates. And some of these use cases would not have been possible with 5G if we are not able to address this mid-tier device category requirement. And similarly, if you look at the industrial revolution that's happening, and you would think typically that this is URLLC, which is mission critical IoT kind of use case, and it is. And some of the applications here, including AGVs and controlling the robotic arms, which are all latency sensitive and also require high throughput in some cases to be able to even do real-time monitoring. But then there are also other devices that come in an environment like this, which require some connectivity. For example, there's a smart UHD surveillance camera here, or a process monitoring sensor, wireless modular equipment, which would all be connected to on-premise edge analytics, collecting all the data and letting the on-premise edge analytics engine make decisions and relay it back to the controllers that are present on the factory floor. So yet another use case in industrial IoT where NR Lite comes and sits very well with the mission critical IoT. And the third example here is the case of indoor enterprise wearable devices, where you will recognize many of the devices that are going to be here, including smartwatches, fitness trackers, health sensors, and even boundless augmented reality. And this is an interesting use case where, depending on what we wish to serve on boundless augmented reality glasses, this could be a use case that could map to EMBB for one extreme set of use cases, to NR Lite, which you'll see in terms of capabilities is going to fit right in, depending, especially for some of the low-end AR use cases. So yet another scenario where bringing in this device with mid to low complexity and long battery life with reasonable data rates is actually going to enable some of these very important applications. So with all of this, why do we need NR Lite? Are there already some devices and categories that could have addressed this? And the answer is, if you were to map it to a 4G technology, that's probably going to be closer to LTE Cat4, with some of the requirements ranging between Cat1 bis and Cat4, but closer to Cat4 for some of the applications that we talked about here. And you'll see that NR Lite actually is the forward path to LTE Cat4, where it matches very well with what LTE Cat4 is able to do in terms of the capabilities and requirement. But more importantly, it offers the operators a common platform to be able to fit in their mission critical IoT, their EMBB services, their massive IoT, and now this mid-tier IoT, all within the 5G framework without the need to deploy different networks. More importantly, take the benefit of the 5G evolution that's going to happen. As you pointed out, 5G is not static, and some of these use cases are constantly evolving, and 5G is going to keep up with the evolving requirements and make sure the solutions stay up to date. So that's a huge advantage that the operators and the consumers will get out of this migration to 5G NR Lite to serve some of these use cases. So with this background and the kind of applications that we expect to be served, it's a good time to actually get into what exactly is 5G NR Lite and what makes it special that it's able to serve this mid-tier use cases. So in terms of the evolution, where it actually fits in, as you mentioned, so starting off with the high performance LTE use cases, right around release 13, release 14, we had eMPC and NB-IoT defined to address some of the massive IoT use cases. And then starting in release 15, the decision was made that this would also be the massive IoT solution for 5G. And in release 16, that was one of the features that was added, where these devices could actually now connect to the 5G core and be part of the 5G network, including enable in-band 5G NR deployment. So with this, 5G had a good solution to take care of the mission critical using URLLC, and then the enhanced mobile broadband, which was the technology for smartphones, PCs, and high-end XR. And then on the lower end, we had the massive IoT solution. And as I said, the gap in between that started getting addressed, starting with release 17. And there is an evolution path into release 18, which is going on right now. Some of the enhancements are being talked about, and we'll touch upon that, and then going beyond as well. So again, the important point to note there is it's constantly evolving and keeping up with the requirements that are coming through. In terms of the technology enablers that's making this happen, for IoT, you can essentially break it down into 4 important components. How do we lower the device complexity? Starting off with let's say the mission critical IoT use case. And as you pointed out, what we're trying to target here is something which is below the mission critical but above the massive IoT scenario. So how do we lower the device complexity and reduce power consumption, coverage optimization, and how do we make sure that the network is not impacted when these lower complexity devices are entering the network? So these are going to be the 4 key components that we'll address in the next few slides and get into some detail for each one of them, and how NR Lite has been able to make sure that we stay optimized in each one of these metrics. For the device complexity, there are multiple components that have been put in place, starting off with the max bandwidth support that's expected of these devices. If you recollect, in mid-band, for example, eMBB devices are expected to support 100 megahertz. That's a requirement. Whereas for NR Lite, for FR1, which is sub 7 gigahertz, now the requirement is that the maximum bandwidth expected of these devices is only 20 megahertz instead of 100 megahertz. And similarly, for FR2 frequency bands, starting off with 24 gigahertz, thereabouts, it's 100 megahertz. Instead of 400 megahertz. So that's already been reduced, which turns out to be a huge saver in terms of the baseband complexity that we need to carry and the area of the chip that needs to be put in. Along with this, there's no requirement, or there's actually no support to do carrier aggregation and dual connectivity, which means that the device definition is going to be just enough to meet the requirements. And then similarly, the minimum number of RX chains. eMBB was 4 for midband. Now, what is required to be supported is 1 for NR Lite, and there is an option to be able to do 2 again to meet any device, any application requirements. In some cases, as we pointed out, again, it's not a one size fits all as far as IoT is concerned, but the ability to go all the way down to 1 RX antenna actually makes this very attractive, because you can build this low complex to low-cost devices. And then the maximum corresponding to the minimum number of RX chains, the maximum downlink MIMO layers can also again be 1 or 2 depending on how many chains we're supporting there. A change in maximum modulation that needs to be supported to 64 QAM is what is mandatory in downlink and uplink, and 256 QAM becomes optional. So you'll see that now all these options actually help us to fine-tune our devices to the requirements that, or to the application requirements that we are going to build these devices for. And the duplex mode, so in addition to the FDD and TDD, we also have support for type A half duplex in FDD, which can again go a long way in reducing the device cost, because now you don't need the duplexes. That also helps with our insertion loss, helps with some coverage recovery, and the complexity and the cost of the device can also go down because of this. And the upper layer capabilities, this is something that can actually help with the device memory requirements. For example, reduce number of DRBs. We don't have to support 16 anymore. 8 is mandatory, and we can go up to 16 as an optional feature, but what is expected is only 8. And similarly, the sequence number, field length, 12 is mandatory, with 18 being optional. And that can translate to quite a bit of memory savings when we start building the device. So these are some examples of the features that have been put in to help with the complexity reduction. Now, if you look at the power component, as I said, power is yet another important metric for these devices and this device category to be successful. And multiple enhancements came in for this, starting off with enhanced low power mode. So if you recollect the enhanced discontinued reception, or EDRX as we call it, so it's been extended to be close to almost 3 hours now for the idle mode, compared to tens of seconds that we used to have earlier. Again, this is the kind of feature that will allow that the device can sleep for a long time and does not have to use up its battery charge or energy to go monitor any paging occasions that come in within these windows. And similarly, mobility and handovers. This is another feature that you can think of depending on the application. If you don't expect your device to have a lot of mobility, for example, a utility meter, don't expect any mobility for those devices, then we don't have to go make measurements for neighbor cells and figure out if we need to do handovers. The frequency at which we do this can be reduced dramatically. And now NR Lite allows for those options for these devices. And along with that, there are a host of other power saving features. And all the power saving features that we have had, starting with release 15 for EMBB and URLC, they carry over to NR Lite as well. So it's a bucket of features that are all available now for NR Lite, and we can pick and choose depending on the applications that we have and the requirements we wish to target. And the next component is the network efficiency and deployment flexibility. So can these devices be deployed on any kind of network, or are there any special requirements that we need to put in? And the answer is, again, there are a lot of options and flexibility that's put in here, starting with even the optimized resource management. At what point does the network know that this is an NR-like device and different from ENBB? And that happens even when the device is actually making a connection to the network. The network knows that this is an NR-like device, and the network can make the decision about what kind of resources it's willing to offer and what services are expected for this particular IoT device, and put in any special requirements that are needed to support this device, or even access restrictions in some cases, as the case may be. So it offers quite a bit of flexibility to the operators as well. And then the other big component is the NR service coexistence. Now we're talking about several different categories of NR devices that are all going to coexist on the net, on the same channel and the same deployment, starting off with EMBB at the high end with 100 megahertz, and now these NR-like devices at 20 megahertz, for example, for sub-7 gigahertz on the low end. And the design is such that the network on the same channel can support all of these devices, and without any loss of efficiency for any of these devices or services. And we will show you some results based on our evaluations and some of our OTA tests that we have done on campus, where we show that this is exactly how these devices and the network can operate. And finally, deployment flexibility. So we don't have to have a special kind of spectrum to support these devices. The design has been put in place so that these devices can be supported in low band FDD, mid band TDD, licensed, unlicensed, as well as millimeter wave. Again, a huge flexibility that we have in terms of what kind of spectrum can be used for this. And then one other question that comes up often is, okay, now that these devices have been designed to have lower complexity, what does that mean for the device performance and also in terms of the coverage that we get for these devices? Is the same deployment that's put in place for 4-antenna EMBB, does it serve equally well for these devices, or do we have to start making any modifications on the network side? And the answer is no, we don't have to make any modifications. It's going to be the same cell layout, same G-node locations that can still address all the NR-like devices as well. And to do this, there have been enhancements put in place to make sure the downlink coverage is not impacted and the uplink coverage is not impacted. And this is a combination of the coverage enhancements that have happened even for EMBB devices, and in addition, there are again some specifics that have been brought in for NR-like. So, for example, in downlink coverage, you can start looking at the channels that may have some impact in terms of scaling down the number of receive antennas or the bandwidth that we have, because we may lose some frequency diversity. And corresponding to that, given the fact that we may not be as latency sensitive now, so you can start thinking about bundling transport block sizes across slots. For example, with transport block scaling, you would actually get the benefit of lower code rate for the same payload that you have to transmit. Lower the modulation coding schemes, one of the classic techniques you would always have, or to improve the control channel coverage, resort to higher CC aggregation levels. Similarly for uplink, we can go up to 32 repetitions of the data channels, transport block processing over multiple slots, which is the uplink equivalent of the transport block scaling that we could do, or inter-slot frequency hopping to get around the 20 megahertz, because with 100 megahertz you get a lot more frequency diversity, but you can get to a similar effect by using different chunks of frequency spectrum across the slots, and then dynamic indication of uplink control channel repetition if we need repetition for uplink control to improve coverage, enhancement of channel estimation and demodulation reference channel bundling across slots so that we get additional processing gain. See, as you'll see, there are multiple techniques that are all put in place to make sure that there is no difference in coverage, both in downlink and uplink, compared to what EMBB can achieve on the same network. And along with these features, so one of the main advantages of 5G based NR Lite and IoT is going to be these additional features that we can get out of NR Lite, and that includes positioning, which is a very big requirement actually as you start looking at many evolving IoT use cases. Asset tracking, of course, is going to be one example that we can immediately think of, but many other use cases where positioning better than 10 meters, 5 meters, 1 meter in some cases, anything in that range is going to be a huge step up compared to what's typically possible with IoT devices. And with respect to positioning, NR Lite has all the techniques up to release 17 that are already available, and release 18 is where the performance requirements will be formalized. But even starting with release 17, you can adopt those positioning techniques for NR Lite as well. And sidelink, and we'll also show you a quick snapshot of a demo that we have done. Sidelink is yet another way to expand the coverage and to have that mesh network using NR Lite devices, so that you don't have to have every device connected directly to the network, which can be helpful in extending the coverage, and it's also helpful in many cases in extending the battery life on these devices, because the range over which they have to communicate can be brought down dramatically. So this is just an example of many other ancillary features that can also be brought into the NR Lite fold to support the use cases of interest. And looking at all of this, so what's been Qualcomm's role in making all of this happen? And as you know, even starting with 4G, Qualcomm has been playing a fundamental role in getting these key technologies in. And starting off with the 4G foundations, what we had with 5G was um, building on this 4G foundations. And even release 15, which was the starting point for 5G, we had numerous innovations that go in that shaped 5G, including the flexible slot-based framework, scalable numerology, advanced channel coding, which are all now you'll see that given the flexibility that we had, even starting with release 15, that's what enables us to bring in this new feature sets even into release 17, release 18, even though we did not necessarily have these starting from release 15. And then start expanding into new verticals and now strengthening foundations in verticals as we go to release 17 and beyond into release 18, which is where the 5G advanced phase is starting. But Qualcomm has played a key role in each one of these steps in making this happen. And in particular, if you look at NR Lite, this has been a very important category for us from the beginning. We had numerous discussions in the ecosystem to ensure that 3GPP defines this use case and this category to bridge the gap between the mission critical IoT and the massive IoT. And in addressing each one of the components, the 4 key components that we talked about, the complexity of the device, the power consumption, the extended battery life, and then the network efficiency and the ability for these devices to operate together. In each one of these, we've seen the use cases and we've seen the importance to make sure that this is all done exactly the way it should be, so that this does end up being a success. And we're really happy where and how this shaped up in 3GPP and the design that we have now in our release 17. You'll start seeing once these devices come into the market, the kind of impact that they'll be able to make, and the new services that will all be enabled with these devices coming in. So having said that, do want to take a few minutes here to point out, apart from the design and standardization, the work that we have done to also demonstrate that the use case and the features that we've been talking about can all be realized in practice. And this is through a combination of system level evaluations and our OTA network-based tests, where we have shown that all the NR Lite features that we've talked about do translate to gains in practice. So what you see here is actually 4 different snapshots. The top 2 show the kind of capacity that we can get from a network when we have a combination of eMBB devices and NR Lite devices, one with FR1, which is sub 7 gigahertz, and the second one with FR2, looking at millimeter wave capacity. And we will have a short video for the first one and a blow up for the second one. But what you'll also see in the third and fourth snippet here is these additional features that we talked about. For example, the narrowband positioning. With NR Lite, we have 20 megahertz, and we actually went one step further, and we also looked at what we can get out of 5 megahertz, and that's the evolution for NR Lite going into release 18 and beyond, where we're looking at further simplification of NR Lite to address yet another set of categories just below what we're able to get to with NR Lite. And we have videos and videos going over the details of these demos on our website, and you'll see that with the techniques that we have for positioning in NR, even with 5 megahertz and angle-based techniques, we can get phenomenal accuracy, which is unheard of for a system which is operating only at 5 megahertz. And then similarly, the multi-hop relay coverage expansion, that's the side link scenario that we talked about, where helping establish this mesh network can help the devices with their power consumption and the network with overall capacity. So with that, there's a quick 30-second clip here. Maybe I'll just show you a snapshot of yet another capacity scenario with FR2. What you see here is you start off with EMBB only devices, and the main question that we're trying to answer here is when we start adding NR Lite devices, what's the impact on the network resource utilization, which will eventually have an impact on the EMBB experience, and then how many more NR Lite devices we can support. The quick takeaway here on the slide is that you'll notice that even when we had 450 or 900 devices to an existing network with EMBB devices, the network utilization goes up only marginally, and we're able to add this hundreds of NR Lite devices. And you'll also see a similar conclusion in the other snapshot that we had with sub-7 gigahertz, where you'll also see the impact on EMBB and the user pursued throughput, which does not get impacted at all, even when we add 40 devices in that case to an existing system with 4 devices. So that's the key takeaway, that the NR Lite category has been designed in such a fashion that there is no impact on the network to support these devices along with EMBB devices, and there's no impact on the EMBB devices themselves in terms of the user experience. And we can support quite a bit of capacity for NR Lite with what's available in the existing deployments. So having said that, that takes us to our concluding slide here. So in conclusion, very excited about NR Lite device category coming in. We're looking forward to some of the early device and services that will be enabled with this device category. And this is going to play a critical component in realizing our connected intelligent edge vision. NR Lite, as we've seen, is going to be very important in bridging this gap between the mission critical IoT and the massive IoT in terms of both the complexity gap as well as the price and all the other metrics that we looked into. And finally, we're very happy that Qualcomm played a very important role in making this happen, and all our innovations have been paving the way for 5G and the evolution that's been happening starting with release 15. Thank you all for your time this morning, and we are ready for questions. We do have 10 minutes, so hopefully that gives us some good time for the questions. Thank you.
Okay, perfect. Thanks very much, Kieran. I'm going to dive straight into the questions. We have lots of them.
Wow.
The first batch I'm going to kind of put together in one. They're really around, is NR Lite targeting Cat 4 or Cat 1? So this question is, downlink uplink speeds of RedCap are on par with today's Cat 4. Today's Cat 1 seems to be sandwiched between 5G's massive IoT and RedCap. Which direction do you expect companies currently on Cat 1 to move, up or down the 5G tier? And there's a good half dozen questions roughly around that theme.
Yeah, so quickly pulling up this slide here for a reference, and the way NR Lite stands right now, as I said, it does offer multiple options where we can scale it up a little bit up and down as needed. But if you look at a quick comparison of the capabilities that we get out of NR Lite, it's a direct match to what we can do with LTE Cat 4. And I would say applications that map all the way up to Cat 4, going down to Cat 1 bis. Cat 1 bis may be on the lower end here, and there is an evolution of NR Lite that's happening now in release 18. There's a study item that's going on, but the goal there is to actually come up with an evolution of NR Lite which matches with what Cat 1 bis does in terms of the data rates and the capabilities. But otherwise, NR Lite by itself is more of a matchup to LTE Cat 4, I would say.
Yeah, okay. And then there's a question on several questions on this power consumption. How does NR Lite power consumption compare with LTE Cat 1 for similar use cases? And just while you're thinking of that, the similar question comes in. Thanks for the presentation. Can you explain why MCL, I think that must be maximum coupling loss on your chart here, for RedCap is 140 versus 144 despite optimized network coverage techniques you talked about?
Yeah, so in terms of the power consumption, as I pointed out, there are multiple features that have been brought in. In fact, all the techniques that were available for LTE and even EMTC, they've all been made part of NR Lite. And in addition, we have other features that are going to help out the overall power consumption that we get for NR Lite. So in terms of the power profile, we expect this device category to be highly competitive and even better than Cat 1, again, depending on how the implementations are done and what other technologies are carried on the modem and the device in consideration. Definitely better than Cat 4, just given how carefully it's been designed. And Cat 1, in some sense, it's operating at a lower capability than this. So if NR Lite is again addressed to put in just enough capability to match up with Cat 1, then I expect NR Lite to do better than Cat 1 as well. So it's always about, as I said, there is a wide range here that we can address with this device category, and which point is actually being picked and how this is being designed. And at every point, doing a point-by-point comparison, NR Lite will come out ahead, just given the features that we have. And in terms of the maximum coupling loss, as you'll see, it starts off with 140 dB here, and mainly because we're going with 1RX antenna here for the 140 dB compared to the 2RX that's been put on for Cat 4. But at the same time, we talked about the coverage recovery that we have, both in downlink and uplink, that's been put in place if a particular application does need, and if we are able to, again, be somewhat tolerant to latency, then that's one other way to actually address some of the coverage deficiency that we may have with this.
Let's jump to another topic, 5 minutes to go. You mentioned positioning in your intro. Question here, with respect to positioning, 3GPP Release 17 has defined target positioning accuracy of 1 to 10 meter for commercial services and 0.2 meter for industrial IoT. Will NR Lite support this 0.2 meter positioning accuracy, since industrial IoT is one of its main use cases?
Yeah, so as you said, there's industrial IoT use cases for indoor, in-to-in, and then there's outdoor requirements that have been put in. So what's happening right now actually in Release 18 is the techniques as applied to NR Lite are being studied. So Release 17 techniques are available for NR Lite, but the performance requirements have not been specified just because they have not been studied to the extent of figuring out what happens when we reduce the bandwidth to 20 megahertz from 100 megahertz. But what I can tell you is, from what we have seen, we can do better than 10 meters. And it also comes down to the underlying technique that's adopted for NR Lite and the NR Lite evolution. We also have AOD kind of techniques, which are going to help both from device complexity and the overall network resources that are needed to support positioning for all these hundreds and thousands of devices that are expected to come in. Then, but also the other question to answer is, what is going to be the expected accuracy requirement for these services? If it's asset tracker, you're probably not looking at centimeter level accuracy all the time, especially when it's outdoors. And for those scenarios, from what we've seen from our competitive analysis for what we can do with NR Lite compared to existing techniques, we are already orders of magnitude better, I would say.
Yeah, good stuff. Okay, time for one more question, I think. Could you talk about the use of NR Lite with side link? I think you had it on one of your charts there.
Yes. So yeah, let me just pull this up here. Yeah. Okay, I pulled up the slide where we have shown a demo where we have established mesh network, a multi-hop relay here in this case with SideLink and NR-Lite. So as things stand, SideLink is not precluded for NR-Lite. There are some enhancements that are possible. Release 18 now is looking at enhancements with unlicensed frequency bands, and that applies to SideLink as well. But Release 17 techniques by themselves are also available for NR-Lite, as in SideLink is a feature that's available. So we can actually go ahead and implement and have this these mesh networks if the application demands it. So it is available, but there are some enhancements that are possible that we propose to take up in upcoming releases.
Okay, good stuff. Thank you, Kieran. With that, I'm going to bring the webinar to a close. We're coming pretty much to the top of the hour.